Okay, good morning, everyone. Another one day where we will learn something new, and this is a very important topic and absolutely a new topic, and even I'm looking forward for this topic. In these days, in every conference, this is a topic of discussion in every branch: intelligence and machine learning. And this topic will be taken care by TMH Mumbai team. And I request Dr. Joyita to introduce his speaker and moderator. Dr. Joyita is head of the Department of Palliative Medicine at TMH Mumbai. Uh, Whatever questions, you must be having a lot of questions in this area. Please write down in the chat box, and Dr. Prasun and Dr. Joyita will take care at the end. Thank you, Dr. Joyita. Please introduce speaker and moderator. Thank you.
Thank you. Thank you, ma'am, and good morning to ma'am and everyone here. It is my pleasure to introduce Dr. Parth Sarthi Jha, who is going to be speaking on this important topic. Parth is our first year junior resident in Department of Palliative Medicine, Tata Memorial Hospital. Parth is very interested in pediatric palliative care as well as pain management and end-of-life care. Parth is a keen sportsman and he's a champion in badminton, and he plays chess as well. So Parth will be presenting on this topic, and he is very sincere and he is very enthusiastic and also a good teacher. So when he presents seminars, he asks us questions in between to see if we've been paying attention. Hopefully he won't do that today. Next is our moderator, Dr. Prasun, who is currently assistant professor in palliative medicine at our APTEC hospital in Navi Mumbai. He passed with distinction his MD palliative medicine in 2021. He has received numerous awards before, as you can see, both in his undergraduate days in different disciplines like medicine, surgery, and pharmacology and pediatrics. He is a member of the Palliative Care Clinical Studies Collaborative of University of Technology, Sydney, as well as the Cancer Symptoms Trials Collaborative and the PACCSC Cardiovascular Disease and Stroke Research Hub. He's a member of ASCO as well as ESMO. And for those of us who know Prasun well, you know, and I have said this before, that Prasun is the epitome of evidence-based medicine. He is also very innovative and is continuously thinking out of the box to improve patient care and patient management and clinical practice. And of course, he is an excellent teacher. So Prasun will be moderating this session, and all questions to be directed to Parth and Prasun, because I really don't know much about this topic. Over to you, Parth.
Good morning, everyone. Am I audible?
Yes, you are.
Let's start with today's topic, artificial intelligence and machine learning palliative care. It's perhaps a very interesting, very intriguing, newfangled topic. And what comes to your mind when you say artificial intelligence? So maybe you think of robots, maybe you think of ChatGPT, maybe some dystopian future movie. But then today, AI is already everywhere. So it finds its application from your browsing history being used for algorithmic suggestions to your heart rate being synced to your smartwatch. It's deeply mingled everywhere in your life and continues to be more so. It's blown up now, but its development started way back in 1950s. So this guy, Alan Turing, he's considered the father of AI, and he proposed a simple test in which if a machine can trick you into thinking it's a human, it passes that test. And the development and progress of AI has had its fluctuations up and down, including a period of almost 20 years where basically no progress happened. That's called the AI winter. This is a picture of Gary Kasparov, the then world champion, playing Deep Blue, IBM's Deep Blue deep thinking technology, and he lost to it in 1997. So recently, ChatGPT has come up, and it's an AI chatbot that became the fastest growing consumer application to date. And as a response to that, Google has introduced its own Lambda software called Google Bard. So what is AI? It's the ability of a machine or computer program to learn, reason, and perform tasks that would normally require human intelligence. So it's going to use advanced algorithm and statistical models to interpret complex data. And then it can use this data to recognize patterns and make predictions on that data. So the European Union defines it as systems that display intelligent behavior by analyzing their environment and taking actions with some degree of autonomy to achieve specific goals. In this presentation, we'll see basic terminologies, understand a little bit of how it works, the general implications in healthcare, and applications and potential applications in palliative care, and ethical concerns. Some of the key areas of AI research are machine learning, language processing, deep learning, computer vision, and robotics. So machine learning is essentially a part of artificial intelligence, and deep learning is a part of machine learning. Machine learning is the part of AI that focuses on improving the perception, knowledge, and thinking or actions based on the experience it gathers. So as time goes on, it gathers more data, it uses that experience to improve itself. And this is built upon neural networks. And it amalgamates data from computer science, psychology, neuroscience, statistics, and control theory. So let's see how a neural network works. Okay. So an artificial neuron is going to receive a signal, and the signal will be a real number. Earlier it used to be a binary number. Now it's going to be a real number. This output of each neuron is going to be computed by nonlinear functions, which will be the sum of its inputs. The connections between these neurons called edges. So these neurons and edges will have weights, and as the learning proceeds, these weights will adjust. And there are 3 or 4 layers. So imagine the input comes in, there are hidden layers in between, and then that will generate the output. So these hidden layers are going to add their modification onto whatever input they receive. And there'll be some inherent learning rule, which is going to draw on the experience of the data that is presented, and that is going to change the weight of the strengths. Further, these neural networks can be convoluted. So convolutional operation is basically a mathematical function in which it takes 2 functions as input and produces a third function, which is the convolution of both. So in this context, the image is one input, the filter is another input. So filter is like a small matrix of weights, which extract features from an input image. And this is going to produce a convolution. So this is used extensively in analyzing visual imagery, and pattern recognition, pattern segmentation is used for facial recognition and image analysis. Deep learning, like I said, is a part of machine learning. So it's the class of machine learning algorithm that uses multiple layers to progressively extract higher level features from raw input. So not only is it going to improve with experience from the data, it's also going to add data to that. And they're hierarchically organized like neurons. And the deep here refers to the number of hidden layers. So more the layer, the deeper the learning method. And it has better generalizations from small data and better scaling to big data. So this is going to identify patterns in data, which are used to make predictions for new data. Let's see how this works in a real scenario. So your input data will be some clinical data, say health records or CT MRI imaging. That's going to be pre-processed, and it's going to go to the input layer. It's going to pass through multiple convoluted neural networks. Then it's going to produce an output and an inference that has meaningful data for you. For example, therapeutic response or survival prognosis. In healthcare, AI can be used all the way from, it can be used in prevention, it can be used in triage and diagnosis, in diagnostics, in clinical decision-making, in care delivery and chronic care management. So let's take an example how it can be used in drug design. So from the conception of the idea of the drug to be designed, to predict its 3D structure, its drug-to-drug interactions, to find its specific target. And then when you produce it, the logistics of how it's going to be produced, the cost reduction. So every part of it, AI can influence. In prevention of diseases, AI can create personalized models and health plans which are tailored for that individual. So it can perform a deep phenotyping, it can analyze the lifestyle, the genetics, the disease history of that individual, input all that data, apply it to a larger pattern, and then produce a personalized plan for that individual. For diagnosis, all these convolutional neural networks that I talked about are used extensively in radiology and pathology. So most of current FDA filed patents are around radiology, and they can be used for diagnosis of skin cancers, dementia, TB, early detection of DM. This picture the picture on the leftmost shows MelaFinds. It's a device used for detecting melanomas, and it's FDA approved. The picture in the middle is Viz AI app. So that's used for it uses artificial intelligence in an app to detect intracerebral hemorrhages. And the picture on the right is Semantic MD box. So it's connected to PACS, and then it screens X-rays for characteristic TB findings. In context of oncology, most of AI is again used in image analysis. So this graph shows you the stage of development and the stage of deployment. And as you can see, the triangles here actually show you the secondary level of prevention, and the diamonds will show you the tertiary level of prevention. So as you can see, most of the usage is actually in image analysis, and the least amount of usage is actually in behavior modification. This picture is of an AI stethoscope. So you just plug it in, it'll record the data, it'll tell you what it matches. And this picture on the right is a hybrid assistive limb exoskeleton. So overall, we can say that there are benefits in cost reduction, in error reduction, in increased accessibility in healthcare, and in better medical education. This is a snapshot of an interaction I had with Google Bard. So I just asked point blank, what is the use of AI in machine learning palliative care? And gives you a very good answer. It says you can predict patient outcomes, personalized care, identify patients who need palliative care, improve communication between patients and providers, and reduce costs. So going to the uses of AI in palliative medicine, can be used for symptomatic management, prognostication, monitoring, research and data analysis, NLP, that is natural language processing, care coordination, and all this together will help you in decision making. So coming to symptom management and prognostication. Symptom management, AI can be used to predict symptom patterns that fit a clinical picture. So they can individualize management for a particular patient, and then they can draw broad conclusions based on all the patients. This can be done using big data. So big data essentially has 4 V's as characteristics: high volume, a variety, a heterogeneous type of data, a lot of velocity as to which that data is created and updated, and veracity, that information being applicable to the real world. So these 3 researches are an example of how big data can be used in palliative context. So for example, Fraser et al. Used big data to collect data that was leveraged to forecast palliative care needs. Karo DC used sleeping big data to predict the relation of sleeping data distress. In patient monitoring, AI can be used extensively. So how to optimize the tracking, the frequency, and the modality of patient monitoring. It will enable early detection of deteriorating health conditions and timely intervention, ensuring that the patients receive appropriate care. Telemedicine is the most conventional way of remotely managing a patient. It's really picked up in COVID era. It increases accessibility, decreases the workload. And if there's an AI software between the doctor and the patient, it can be used for things like annotation, automatic recording, and it'll make the experience a lot smoother for both sides. So these days, multi-agent systems have come up, and they are essentially autonomous software that function constantly in dynamic and unpredictable settings, and they'll react to whatever events happen. So they show properties of sociability, that is, they can be interacted with, and they can interact within their own proactiveness, as it's going to do things on its own with a degree of autonomy without your intervention. and reactivity. So whatever dynamics change, whatever parameters change, it's going to adjust to that. And they're very efficiency oriented and they reduce the workload. Smart sensor technologies also started coming up. So these are minimally invasive designs and they offer undisturbed mobility for patients. And they prevent these physically restraining invasive ways. And they can provide very long-term data without burdening the patient. So basically 24/7 monitoring without burdening the patient. This is a paper that spoke about smart sensor technologies in palliative medicine. And as you can see in conclusion, it cautions us about losing some aspects of total care principle if you are over-dependent on smart sensor technology. For prognostication, most of current use of AI and ML in palliative medicine is for predicting mortality and survival analysis. So apart from that, natural language processing and research and data analysis are other two applications. So in natural language processing, there were some researches done about conversational pauses. So the conversation between a clinician and the patient was identified and it was recorded. And the AI algorithm tried to identify snippets of conversational pauses which are meaningful, which help you connect with the patient. So silence, but which is meaningful. And and further than it was verified by independent human verifiers. So it showed a very remarkable rate of success in identifying those snippets of conversational meaningful pauses. And it was also used in research to identify goals of care conversations. The entire conversation has been recorded, and it would try to identify where the goals of conversations were discussed. For research, AI was used for predicting the need for palliative consultations, and it started referring on its own. So this showed a decrease in 60 and 90-day hospital readmissions. And it can identify patients who are at a risk of high or medium short-term mortality. It was also used in research to predict morbidity. So Gao et al. Used it to predict lung infections in patients, and it showed superior performance of neural networks. It was also used to predict the response of palliative therapy, but that did not result in any additional predictive value. Apart from that, it can also help you in making decisions. So it can provide evidence-based recommendations. It can analyze that patient's data, suggest something appropriate for that patient, how to tailor the treatment for that patient, for example, dose adjustment and interventions. And it can correlate that with existing guidelines and data available for your context. So this smart art just shows you how to make decision makings. For example, you'll incorporate the general condition, the ECOG. You'll evaluate the likelihood of tolerance of disease-directed therapy. You'll rely on clinical and imaging data. All that will lead you to evaluate the risks and benefit. This is where the AI-based evidence data comes in. And all this will help you to make a more informed decision. So it will support decision-making by identifying those at heightened risk of inappropriate care, poor outcomes, and mortality. Potentially later, advances in model explainability, like say GradCam, can display areas of an image that a neural network is basing its predictions on. So not only will AI have its input, you can also see where that input's coming from. So this is something to be seen in future. And you can see where the AI has derived its suggestion from, and you can consider that in your decision making as well. So this in one paper, the specialist palliative care physicians, like people in this group, were interviewed about what they think of AI. And most of them had not used it, but most of them had a very positive outlook. And they commented that it would be very beneficial, mortality, morbidity prediction, identifying individuals with potential to benefit from palliative care interventions, and evaluating individual patients' response. But they had concerns about data governance, confidentiality, psychological harm, the accuracy of the data. And they recommended that future research be done in the ethical and the practical issues in palliative care. So coming to ethical concerns, which are many in AI use. Privacy and confidentiality. So AI systems, they require access to very sensitive patient data, and they personalize care. And this might be sent to a third party further. to analyze that data. So security protection for data is paramount, and this must be ensured. Informed consent. So patients should be fully informed about the use of AI technologies in their care, and they should have the opportunity to provide informed consent. They should understand how the data is being collected, how it will be stored, how it will be used, and they should be given the option to opt out if they choose so. Bias and discrimination. So AI use can inadvertently perpetuate bias, and biases have to be addressed and they have to be evaluated, and they have to be regularly monitored, and auditing of AI must be done. So this infographic shows you how bias can affect AI use in every which way. So from the data that it's picked up on, from the design that's implemented in it, to its use in real world, how it can perpetuate, injustices, and how it can affect use of AI can affect real world inequality. Coming to human oversight and responsibility, though, so legal liability is a big question in use of AI. Even if it's FDA approved, who is going to take the fault? So it'll be the manufacturer or it'll be the clinician using it. And AI is not to replace any human judgment or responsibility. It's just a tool to aid your diagnosis, to aid your treatment. And adequate training for interpreting the AI results and AI recommendations needs to be given to people using it. And they have to be aware of limitations, and they have to be aware of potential errors in AI systems. This is a paper published in Lancet and talked about how use of AI in palliative medicine can risk ambushing contextual conversations, how the bias is embedded within the databases, and that can be perpetuated by use of AI, and how it might overlook the contextual variability of that case and prioritize reductionistic interpretations. Another concern is transparency and explainability. So AI algorithms are complex, and it can be very challenging to understand how they've reached a certain output. So there's a branch called XAI, called Explainable AI, and the entire branch is just dedicated to explaining how one AI can reach its output. This ensures accountability. This is an example of how, say, explainable AI can be used in pathology. So its structure should have transparency as to the structure of the network should be known, the activation status of neurons should be known, and the semantics of the meaning of the network component. So what it characterizes is what needs to be known. And the explanation has to be provided as to why it's reaching a certain output and what it's basing it on. In end-of-life decision-making, AI can offer some recommendations as to treatment options, but again, it's only a factor in decision-making. It should not drive your management. It should just aid it. There can be certain unintended consequences of AI. So for example, it can erode the patient-provider relationship. It can dehumanize care a bit. It can make it a little more mechanical. And it can increase the healthcare disparities. So as we know, palliative medicine is a high-touch, low-tech branch, but it can be high-tech and high-touch. It doesn't have to lose its touch. And so we have to align it with the core principles of palliative medicine. In conclusion, I would like to say that AI and ML can be integrated in palliative medicine in a lot of ways. And there are new and innovative ways that support evidence-based medicine. And they are just tools to augment your clinical decision-making, your treatment, and they should not replace you in any manner or form. And we have to be cautious about the ethical concerns. Thank you.
Parth, excellent it is. It was excellent. Whatever, as a first-year resident, I think I can say that you have gone through the literature so well. It was absolutely a new topic. Joyita and Prasun, please go ahead with the discussion.
Can Archana allow Prasun to unmute, please?
Okay, thank you. Thank you, Parth, for that wonderful presentation. So Parth had put in a lot of efforts to learn machine learning and AI, and I had to take some help from my brother, who is a computer engineer, to learn this thing. So I can't see any comments or questions in the chat box. So I hope that you have got some idea about AI and its potential use in palliative medicine. Is there any question? Or is there anyone who still has some doubt about AI?
I think I think all of us are new to this topic, Prasun. So most of the comments which are coming is congratulating Parth for an excellent presentation. There is one question which has come in now. Can you see?
Yes. Okay,
about
so,
how we can contribute to machine learning.
So this is the question from Punitavati. Can you tell us how we can contribute to machine learning? Yeah, thank you for that question. So we as clinicians and the engineers who make this AI work come from very different backgrounds. So they work with algorithms, the data sets, or pure objectives, what they want to find and how to find it. And we as clinicians work with patients. So we do have like different options, different inputs, etc. So the basic data, what we want to get from AI is to be given by us. How we get it is what the engineers do. So what exactly we want, that is something which we have to define. What are our objectives? What will be the inputs and what we want from AI? All these three questions needs to be answered by us as clinicians so that they can work on it. So it includes the data as well as what will be our objective and how or what exactly we want AI to do it. This is to be done by us. And this needs to be done as per the requirements of the AI building team, who will definitely ask you what exactly you want, and that's how it works. What is the role of dosing?
There is one question from Dr. Meenakshi Prasun.
Okay, ma'am, I'll just see.
How much is the mismatch between human analysis and AI? What is the margin of error?
How much is the mismatch between human analysis and AI? What is the margin of error? Okay, so the AI can't go more than 80% accuracy. That is what is known so far. So no decision can be completely made just based on AI. So AI can suggest, as the accuracy is usually not more than 80%. So the final decision maker will always be humans or the doctors.
There are two more questions, Prasun. Yeah, thank you, Prasun. Thank you. And I know that you have guided Parth a lot. Yeah, so there are two more questions. Yeah.
Okay, yeah. So what is it? How do we address the quality and the biases of the data? Those are used to train the AI algorithm. Okay, so addressing the data, the algorithm biases are not completely our responsibility, one. Second thing, so the engineers or the team who develops this AI will be taking inputs that we direct them to. So that is one of our responsibility, that we give them the right data, or not a skewed data or not a biased data, that it comes up with an algorithm which will provide you a biased result.
There's one more question.
Yes, ma'am.
About DOSI.
Okay, what is the role of DOSI? Go on.
From
monitoring apparatus with
DOSI is a Bangalore-based remote sensing startup, and I think it uses FDA technology connected to the bed of the patient. So it's basically a remote sensing technology, but it's not very autonomous right now. It just provides all the vitals in a very crisp and concrete fashion, and it can be used for around-the-clock monitoring.
Okay. Thank you, Parth, for that.
So this DOSI is made by a startup from IIT? this where they have put the sensors on the bed. So we will keep getting the inputs from the patients, various inputs from the patient. So that is what I think just now Naresh told me, because he is listening everything on this topic.
Good one. There's one more
Yes, ma'am.
precedent part.
Yes,
Is
ma'am.
the implementation of AI practically feasible in low resource remote settings? And is the effectiveness of this more than the cost? I guess we'll only know when we actually do the.
Yes. So this one, just a question about that. Then after that, I'll answer this. So please iPhone to everyone. How much is the human accuracy? That will depend, ma'am. It can vary from less than 33% potentially and maybe up to 100% depending upon the human. So there's no data which I can say.
Yeah,
So
low resource set. I mean, in our settings, effectiveness. We will still have to do the studies, right? I mean, we know the practical applications. We know our responsibility of giving the right data for creating the accurate algorithm. So a lot depends on us, I guess. And
Yes,
is there any regulatory frameworks and legal challenges surrounding AI?
so I'm adding to Mamta Parihar's question. So I would like to say that yes, even in low resource setting, AI will be applicable to a lot extent. For example, if you look at Google Bard or Chat GPT, you're still using it. Most of us who are sitting here are getting personalized suggestions on our phones depending upon our browsing history. So yes, AI has already come into even low resource setting. Even the person who is in the interior most of India, who is using a smartphone, still gets his or her suggestions depending upon the browsing history. So AI has even reached there in that context. So if we implement that in for healthcare, I guess it should work.
Thank you, Prasun.
Reassuring to know that we will still hold our jobs. Yes, definitely. So AI can't take the place of doctors. AI can suggest for, I'll give you an example in the last, if I finish all questions, how it works. Is there any regulatory frameworks and legal challenges surrounding AI? Yes, there are a lot many legal challenges, regulatory frameworks and legal challenges. So pinpointing each one of them, I'm not sure this would be the right platform for that, but yes. So I have attended the AI seminars and how AI works. So yes, there are a lot many regulatory frameworks as well as legal challenges for that. My experience in every time when you reach out for an AI for assistance, you can always ask it to give the references from which it is giving us a suggestion. Many times it suggests to take us to the final. Yes, this is what he has told in the last few slides. This is how we can make it more transparent, that we ask the AI algorithm how the algorithm works, from where the inputs have been taken, what was the algorithm used, and how it has come to the conclusion. Does AI use data from articles available only from I think it's articles. Does AI use data from articles? Yes, AI use data from articles, which is available only from PubMed. Now I didn't get that question. If you're asking me that if AI uses the data from published papers, then my answer is like yes. For example, you have an app called Consensus. Consensus is an AI-based app where you can just ask the app a question like, is octreotide useful in malignant bowel obstruction? So that will come up with yes or no. There's a poll thing. It comes to that. If you ask it a yes or no question, it answers in a yes or no fashion, and it provides all the articles which it has taken the info from, and that's an unbiased. So whatever is available online that uses data from those articles, it quotes the article which is the most cited one, which is given more weightage. So it gives weightage according to the citations or the study type. If it's an RCT, or if it's a systematic review, it gives more weightage to that. And then it comes to conclusion. So apps or platforms like this already exist and those are free. So yes, it is. It do uses the data from the published articles. So I hope that answers the
Parth,
question, Srikanth
Parth,
sir.
I want to ask you one thing.
Yes, ma'am.
We gave this topic to TMH Mumbai, and Dr. Joyita gave this topic to you. What went in your mind when you were preparing this topic with Dr. Prasun?
So ma'am, I had like a very little experience with machine learning because for a brief time I was in MD biophysics course in AIMS Delhi. So I had a little bit of idea, and but to extrapolate that to palliative medicine was like a lot of like literature research because of not a lot you can find off the first look. But it was interesting and I got to learn a lot. So I like that.
Good, very good, Parth. So, Prasun, you want to add something?
Yeah, so just if someone has still doubt how AI works, so a very simple example, suppose we have dementia patients who are unable to communicate and we are looking for pain in them. We use the Dolo Plus questionnaire, but how often do we use it? Once a day, or at what point of time? When we are free or we are going for rounds, and that requires a lot of time as well as human resource. But what if we can monitor the patient with AI tool, with sensors, and then put an AI algorithm to it, and it clearly says at what point of time. It can't predict 100% surely that how or when the patient is in pain, but it can say that when patient is not in pain, when all the parameters are okay using the sensors. So that possibly tells us that that is not the right time to administer a questionnaire or to look for behavioral or behavioral symptoms or behavioral signs to see whether the patient is in pain. So this is how AI can help reducing the human efforts. So that can tell you during these hours of time, this is not the right time to check for it. You can possibly check when the patient is possibly in pain, or not to check when the patient is not in pain. So this is how AI can help. So it can't say whether the patient is in pain completely, or it neither can say the patient is not in pain completely, but it can suggest us when to look for pain. So that's how it works. So it won't take away our work. It will just help us reduce the time which we spend or to use the time more effectively.
Thank you,
So
Prasun.
just
Excellent example. Excellent example. Dr.
thank you.
Punita, we will send you all the links. We will take links from Parth and Prasun and send it to you, everyone. As such presentation, Archana is sending, but definitely we will send all the links which they have used. Dr. Joyita, you want to add something?
I know, just to say that thank you, Parth, and thank you, Prasun. It's been a really great morning for learning today. And I just sincerely appreciate the effort that you, Parth, along with Prasun's guidance, and Prasun's also worked a lot, have put in for this particular presentation, for the benefit of all the palliative care professionals in the country. So thank you. And I think I made the right decision when I gave the topic to you, Parth, and to you, Prasun, as the moderator. So thank you very much. And thank you, ma'am, and thank you, everyone.
So Parth, before we end, I think this was a topic which is like automatically everyone was interested to learn new things from you, and you did justice as a junior resident of palliative medicine. This also shows that the way palliative medicine is growing all over country, we are on the track, and especially when we know that we are developing. I should say that we are forming our concepts as a normal intelligence, but you have spoken something for half an hour on artificial intelligence and on palliative medicine. Definitely, I would like to recommend that our residents, those doing MD and DNBs all over country, their their supervisors should think of giving some MD thesis topic or DNB thesis topic to their students. It's like small things we can start with in area of artificial intelligence as well, so we can create our own evidence and our own data from India. So thank you, Joyita. Thank you for a wonderful team you have chosen for this topic, Parth and Prasun. And thank you everyone for joining. Your joining makes a huge difference, and it gives encouragement to speakers and moderator both. And thank you, Archana and Nisha, for keeping everyone on track. And we will see you next week before 6:30. Thank you very much.
Thank you, ma'am.
Thank
Thank you.
you.